at Trinity College Dublin and is the co-founder of the Trinity Centre for Environmental Humanities. His main research interests lie in climate history, and he has contributed to many projects which have used analytical techniques of physical geography to explain periods of social change and conflict throughout ancient and medieval history. So Francis has been working on so many projects, so many publications that if I had to list all of them here, there wouldn't be any talk today, any time left for this talk. But I just want to mention a couple of projects he worked on. Climate, one is climate as a catalyst in 1,224 years of violence and conflict in Ireland, AD 425 to 1649. And another one, historical dynamics of violence, conflict, and extreme weather in medieval Ireland. So it's currently the PI of the IRC Laureate Award funded project entitled Climate and Conflict in Ancient Babylonia. And Francis today is talking about what can ongoing advances in ice-based volcanic eruption histories tell us about human history, examples from ancient Egypt, Assyria, and Babylonia. So, Francis.
Thank you so much. Okay, it's great to be here. Thank you for the chance to present what is hopefully going to be an interesting example of interdisciplinary work of the sort that I think really demands collaboration between historians, archaeologists, climate scientists, and others. For my own part, I call me a climate historian, and my specialism is really in finding information about climate, weather, and its influence on societies from written records, but there are obviously many other sources now of information about past climate conditions, principally coming from what we might call natural archives. That includes things like tree rings and ice cores, as well as climate modelling that can also help fill in the gaps for periods and regions where such evidence is thin or non-existent. So my talk today revolves around the use of ice core records and the increasingly detailed record of past volcanic eruptions that they are now providing us with volcanic eruption dates and the likely magnitude of their climate impacts now available to a chronological accuracy of about plus or minus 1 year, say, for the past 3,000 years or more, something that is being extended on an ongoing basis in work by Michael Siegel and others. And we're going to come back later to how these ice cores, which are the product of drilling deep, sometimes several thousand meters, into the great ice sheets of Greenland and Antarctica, how they actually provide us with archives of past explosive eruptions.
So just to let you know, on Teams, you can share the screen so that the people from home can see the slides more clearly as well.
Okay, should I do that?
Please.
Yeah, let's try that.
Can I help?
Where's it usually?
The share button at the top right hand side of Teams.
Oh, it seems
But you need to give him permission.
Okay.
Okay.
Thank you so much.
No problem.
That should just be the slides. Okay. Okay. Brilliant. Great. Back into the presentation. Okay. Great. No problem. Okay. So first, though, why are these eruptions significant to historians or other scholars? Well, here we see the 1991 eruption of Mount Pinatubo in the Philippines. That's pictured to the left, and it's one of the biggest eruptions of the 20th century. It injected large volumes of sulfur dioxide into the stratosphere, where it formed an aerosol haze that scattered or reflected incoming sunlight back to space, thereby cooling global surface temperatures for about 3 years. Obviously, it didn't reflect all the incoming sunlight because we still could see during the day, but it still reflects a meaningful amount of sunlight so that it can impact climate. Now you can actually see several distinct aerosol layers in this image of the stratosphere on the bottom right, taken from the space shuttle in the months just after the eruption. And you can compare that with the clear stratosphere in the top right image, also taken from the space shuttle, but in the years preceding the eruption. So now not only do these eruptions affect temperatures, but by causing cooling, they also then have knock-on impacts on precipitation globally. But one basic mechanism by which that happens being that cooler temperatures will lead to less evaporation over water bodies and ultimately somewhere else fall as precipitation. It has these eruptions have other effects on precipitation too, through slightly more complex means. We'll come back to that. So how should we use information if we had it on past volcanic eruptions for the purposes of understanding the potential influence of climate on past societies? Well, one way that environmental anthropologists have seen climatic hazards is as revelatory crises, which is a useful framing, I think, for historians and archaeologists too. So in that framing, climatic hazards can be seen as activating or maybe exposing fault lines, tensions, or vulnerabilities in a society that might be latent or at least partially hidden or unremarked upon in the absence of a sudden shock to the system. And this framing also provides a model for social change or societal change at these times, in that sometimes the system can be seen to change in response to these shocks, past disasters or climatic hazards, either because of their material or psychological impacts, or because they allow room for innovation by disrupting the status quo. Say we've seen that with COVID, or because they make apparent and perhaps justifiable the need for adaptations to the way things have been done up to the disaster, if the way things have been done have seemed to contribute to the impacts of that disaster. So for my purpose, I'm also interested in seeing how we might take multiple dates of historical climatic shocks of the sort that might be expected to follow big volcanic eruptions and use these to sort of test, even statistically, for vulnerability and responses in whatever aspects of past society we can get good data on or good evidence. When attempting this, it's going to be extremely important to understand that the social, political, and economic context of the period and society in question is going to have a major impact on how any sudden shock sort of works its way through that system, even if indeed it has an impact. So today I'll mainly take the case of the Ptolemaic dynasty that ruled Egypt between 305 and 30 BC, after Alexander the Great had conquered the region. Now, the first Ptolemaic king, Ptolemy Soter, or Ptolemy the Savior, he was the handsome guy pictured on the coin to the right here, had been one of Alexander's key generals, and he took control shortly after Alexander's death of Egypt. Now, like Alexander, the Ptolemies were of Macedonian Greek origin, so this is actually quite a fascinating period of Egyptian history because of the mixing of Egyptian and Greek cultures and traditions that persists and mix through this period. In the archaeology of the period, that you'll see sculpture like this on the left in traditional native Egyptian style, but you also see and find coins like this, which are effectively a Ptolemaic introduction, coinage monetary system to Egypt. The period is also famous for its material and its cultural achievement, including things like the founding of the city of Alexandria, named after Alexander, of course, on the Mediterranean coast, with its famous Great Library and Lighthouse, which is pictured on these coins to the right, from the 2nd century AD. Now, much of the ancient city is now underwater, unfortunately, because of subsidence. But we know a lot about the material wealth of the city thanks to underwater archaeology and the written sources that survive that period. And here to the left, we have an image of a 6-ton red granite statue of Hapi, who continued to be worshipped during the Ptolemaic period. So there was a continuity of older Egyptian mythology and traditions and sort of intermixing with Greek Macedonian traditions and mythology. So very interesting period. Now, Hapi was the god of the Nile, the god of the Nile's annual summer flood, to be more specific. And the effort, I think, that went into carving such an immense statue out of what was a single block of granite is a pretty good indication of how important the summer flood was to Egypt. Now, the Ptolemies ruled during a period of highly competitive states with near continuous warfare between them. In particular, they were at war multiple times with their great Near Eastern rival, the Seleucid Empire, which was consolidated by Seleucus Nicator, another former general of Alexander. And you can see here the Seleucid territories depicted around 275 BC. They're outlined with the grey dashes here, and the Ptolemaic territories are outlined in green. Now, despite knowing the dating of many major events involving these states, including revolts, internal revolts, and warfare between them, the forces that drive or drove these things are actually not as well understood as we might wish, given the massive amount of documentation that survives from these states. They tell us that things were happening, but they don't often tell us why they were happening, and that's left up to us to try and discern. And the role of the environment is usually absent from modern histories of the period as they try and discern what was driving all of these major events, major warfare, and major revolts, for example. But in terms of environmental influences, we can learn a lot, I think, just by looking at the regions that were actually contested between these two states, the Seleucids and the Ptolemies. And they're shown here in the red boxes on this map now. And all I've done here is to situate them against a map with regional rainfall patterns, which is shown in the red-blue shading. Red is drier and blue is wetter. And it's these blue shaded coastal regions where most fighting actually took place. Now, the ongoing warfare between the Ptolemies and Seleucids is usually explained in terms of dynastic and political feuding, and a culture that expected the kings to frequently campaign to sort of demonstrate their authority and secure territory for the glory of the kingdom and of the various gods and so on. But I think even this simple mapping exercise pretty quickly suggests that there's an overlooked story, very little remarked upon in any of the modern histories of the period, in which fighting centered over access to rain-fed agricultural areas or territories, places where you could grow wheat and barley just with the local rainfall without irrigation. And it actually makes a lot of sense if you are Ptolemaic Egypt and your dominant source, as we'll see, of water for agriculture is the Nile, that you might try to secure external territories that don't need irrigation to deliver you an annual wheat crop, for example. Now, while the Nile is sort of famous in allowing Egypt to be one of the most agriculturally productive regions of the ancient world, the river is also famously variable, and famines are well attested in Egyptian sources throughout several millennia when the river suddenly didn't provide sufficient water. And you can see also from the red shading on this map that most of Egypt is effectively desert and doesn't receive any local rainfall, apart from occasional sudden thunderstorms that actually don't provide enough water and are more damaging to crops than anything else. The Ptolemaic era is pretty famous, and there have been many written histories of it, not just modern, starting very early. But when you look more closely, if you look closely at most modern histories, they actually still continue to base their framework or their narrative framework on the history of the state written by Polybius, the ancient Greek author of the 2nd century BC. And according to Polybius, after an initially successful period under the first three Ptolemies, first three kings, the state begins to decline, its fortunes starting to deteriorate because of poor leadership. And Polybius cites the kings turning to drunkenness and womanizing and not paying attention to their kingly duties. And hence, you also have the native Egyptians repeatedly revolting against Ptolemaic rule because of this, and eventually the state falling to Rome in 30 BC. That's sort of simplifying things somewhat, but it's not really too far off the mark in terms of what you'll read in most contemporary histories. And again, here there's no role for the environment, despite what we've just seen and how dependent Egypt was and is on the Nile. Now, we certainly do know that the Ptolemies, as I've alluded to, experienced considerable instability in the form of major revolts, organized revolts. And we know the dates of these reasonably well from the surviving papyri, and though there are always some uncertainties over the precise dating, the precise year. Now, sometimes the scale of these events is, people are waiting. Sometimes the scale of these events is in question. Are they local? How local are they? Are they geographically widespread, for example? But this slide just lists the very prominent events, those we think are not just local food riots and appear more like large-scale organized attempts, often with military involvement to overthrow the Ptolemies and institute perhaps a native pharaoh again on the throne. Now, one of the most, for example, most significant of these events is known as the Great Theban Revolt, and it starts in 207 or perhaps 206. And a good account of it is inscribed on the Temple of Isis on the island of Philae in the Nile, and it describes how the The rebel against the gods made war in Egypt, gathering insolent people from all districts, and they did terrible things. They sacked the towns and their population, women and children included, committing all kinds of crimes in the time of anarchy and so on. So this sort of condition persisted for about 20 years, and we can see it backed up by an absence of taxation documents from southern Egypt for about 20 years. But clearly the Ptolemies had lost administrative control of a large area of the territory for at least 2 decades. So these sort of events that we're listing here are not minor events. And we also know the dates of 9 wars, 9 sort of big wars between the Ptolemies and the Seleucids, and we have a good idea of their start dates and end dates from treaties between the 2 kingdoms, for example. But we rarely have a complete understanding of why they started and ended on each specific date as opposed to any other date, say. This has posed quite a mystery to historians for a long time. In particular, there's one instance when Ptolemy III suddenly abandons what seems to be one of the most successful campaigns of any Ptolemaic king against the Seleucids, having reached far east as Babylon on the Euphrates, which is deep into Seleucid territory. And that's been a mystery of why he would suddenly abandon this really successful campaign. There's lots of words written over this, but there have been some clues recently that have helped us sort of push on the story, with the discovery of a fragment of a Babylonian chronicle, pictured here, that describes how Ptolemy would have taken possession of all of the kingdoms of Seleucus, apparently, unless he had been called home by a domestic sedition, whatever you can infer that to mean. And there's also a contemporary Egyptian papyrus that describes or makes mention of an Egyptian, presumably native Egyptian revolt internally at this time as well. Another clue comes from one of the most fascinating texts from the period, and this is known as the Canopus Decree. It's dated precisely to 238 BC, so just a few years after Ptolemy abandons this campaign. But annoyingly, it doesn't date precisely the events that it is describing. But by implication and context, they're occurring what feels like quite recently. And they describe panic associated with what is known as Nile failure, sort of colloquially, and more formally, a failure of the summer flood. It's not that there was no water, but it just didn't rise sufficiently to flood enough land to conduct sufficient agriculture to feed the amount of people that was necessary. It also goes on to describe the remittance of taxes, massive importation of grain from external sources, all organized by the state, by the reigning Ptolemies in response to these Nile failure conditions. If you read that there, you can see, that for fear made them think of their deaths, which once did occur in the time of the former kings in consequence of the deficiency of the Nile, and His Majesty Ptolemy III and his wife had care in their hearts and so on. And they remitted considerable tax in order to save men's lives, and took care of importation of corn into Egypt, and expended much gold for the purchase thereof. So this is quite, at least semi-propagandistic, but does give us a further hint as to what might have motivated the revolt in the 240s, and why Ptolemy would have needed to suddenly abandon a successful campaign against the Seleucids. Essentially, the inference is, I suppose, to manage the situation and prevent maybe an partly opportunistic revolt whilst he was away. And this text itself brings the role of climate and the Nile into focus in these events and other major historical revolts like this. Now, one thing we know is that the summer flood of the Nile, which was so important to Egyptian agriculture in the place, again, where local direct rainfall provides no real meaning contribution to agriculture. The Nile flood in the summer is driven by the African summer monsoon, that's well known. And this animation shows the band of monsoon rainfall accompanying the annual reversal of winds, that's sort of formal definition of what the monsoon is, across the equator for each year between 1979 and 2000. So red and purple signify areas of heavier precipitation, and each frame in the animation represents a week starting in January 1979 and running up to 2000. You can see the annual monsoon cycle working its way through each year. Now I've circled the Ethiopian highlights in black, and you can see that as we come to each summer season, that the monsoon rainfall moves up over the source area of the Blue Nile, And this ultimately drives the all-important summer flood of the Nile. So obviously, Egyptian society will be highly sensitive, at least economically, in terms of food supply, to changes in the monsoon. And returning finally to volcanic eruptions, it has become increasingly clear since at least the early 2000s that big eruptions can actually limit this northward migration of the monsoon winds, leading to less rainfall over Ethiopia. We've got good reason theoretically to suspect that big volcanic eruptions in the past should have affected the monsoon as well, and we'll try and look at some other evidence of this, and good reason to assume at least that this should also have had some societal impact, but we'll try and put some evidence in where those assumptions are. So if we wanted to look over a long period at the impact of eruptions on the summer flood of the Nile, then we can make use of the famous Nilometer. So these images show the existing Nilometer on Rhoda Island near Cairo. And despite the sort of ornate surrounds of the existing structure, it functions basically as a simple measuring stick from which the Nile summer flood height can be recorded each year. Basically, how far up the water comes in this chamber is measured off that pole. What remains to us now are Nilometer measurements from the Islamic period, so beginning in 622 and running up to the 20th century. Now, even though this is just actually a fraction of the record that would have once existed, it's still a remarkably long hydrological record in quantitative format, and it's actually, despite that, still overlooked largely by scholars and scientists alike as a source of evidence. Now, this graph shows the Nilometer time series itself, starting in the left in 622 AD and running up to 1468, excuse me, on the right, which is the most complete period of coverage that we have. It still runs into the 20th century, but there's more gaps in it. So this is the most complete coverage if you want to do some analysis. Now it takes a while to sort of absorb the various messages communicated by this graph, I think. Perhaps the most obvious is that it is still, and is the most important, is that it looks like a mess. And you could say that more formally, characterize the summer flood as highly variable, which is indeed one of the defining features of the Nile, long remarked upon by observers from the ancient period onwards. Now, there are also years with very low flood values that stick out here, and I've highlighted one with this red arrow. And we know from work on the medieval and early modern period that these sort of years were not infrequently associated with subsistence crises and full-blown famine and other social impacts of stressors like from mass internal migration to urban areas, abandonment of the agricultural land, basically. If nothing is growing, if the water has not flooded that land, you can't really conduct much agriculture there. You can't irrigate sufficiently, you can't lift enough water out to replace what the system that prevailed there up until the 20th century, which is basically flood recession agriculture. You just let the land flood. You can help it along the way with dikes and canals and so on. But you let the land flood, then you wait for the water to drain away, and then you pounce and start sowing the seed. That was how they operate the system. And when the water was flooding sufficiently and also adding lots of silt to the land either side, you could have fabulously high rates of agricultural productivity in Egypt relative to the rest of the ancient world. But when it didn't happen, there were serious problems. Now, one barrier, I would say, to our understanding of the climate impacts of past eruptions is the limited number of eruptions that have occurred in the modern period, certainly in the 20th and the 21st century, when we've got really good weather data, instrumental observations, even satellite observations to try and track what will happen after a big volcanic eruption. We also, by accident, have the least sort of interesting period in terms of explosive volcanism. The eruptions that have occurred in the period haven't really been that big. Pintu was biggish, but certainly not massive in terms of a long-term context. And they haven't either been that frequent. There's always volcanism going on, it makes the news. But to really alter the climate, the eruption has to get a lot of sulfate straight up into the stratosphere. If it doesn't manage to do that, it won't really have much of a climatic impact. But now, thanks to these icebergs that I introduced briefly at the beginning, we can get a better idea on the dates and magnitudes also of historical explosive volcanism, using precise measurements of the sulfate content in annual layers of Greenland ice. Now, on drilling these cores and melting the annual layers, we get a sample of how much sulfate was in the atmosphere each year, preserved in the ice sheets as it sort of settles out each year from the atmosphere and the influence of gravity, or is sort of captured in snowfall. Basically gets settled out onto the ice sheets, and as more ice, more snow each year accumulates on top of the previous years, the added weight compresses snow into ice. And you can actually see quite visibly, usually, each annual layer of ice. So you can also count the date of that annual layer backwards from the present. Now, to show you just how much things have progressed in terms of using these ice cores and getting data from them, you can have a look at these two figures, which show the sulfate deposition measurements for two periods, one on the top from 1450 to 1470, and the one on the bottom from 1519 to 1610, and these each line comes from two different ice cores. So here you can identify eruptions, and this is how you do it basically. When the sulfate values suddenly rise, they shoot up above the background levels. It's not a gradual rise, it's a sudden impulsive sort of spike of sulfate. And the black line in each graph shows the resolution, or in other words, how finely you could sample and measure sulfate in each of these annual layers from the GIST-2 ice core from back in 1993. When to get one sulfate value from the ice, you need to melt around 2.5 years worth of ice. Given that the sulfate is there really in parts per billion, so even then it was quite advanced to be able to register that, but you had to melt quite a lot of ice just to get one sample of the sulfate. Then from 2012 overlaid, we have the NEEM ice core, in which we were able to measure many samples per year now and detect sulfate into the part per quadrillion if needed. So you can see how, when you're comparing the same periods, this gives us a much better picture and can help us distinguish what might be several eruptions that have occurred closely in time, rather than blurring them together or missing them all together. Effective air conditioning.
It doesn't seem to be affecting the audio that much.
It's good, okay, yeah. Cool. We just got some AC on here, that would be nice. Anyway, and this slide shows one of the most recent, highly chronologically accurate time series of sulfate deposition in Greenland over most of the Nilometer period from 622 onwards. And this was been worked led by Michael Siegel at the University of Dublin. So again, there's always some. Can you guys hear me at least? Yeah? Can anyone? So there's always some sulfate present, but major eruptions, again, potential to impact climate and the Nile, are clearly visible here as these sudden spikes in sulfate deposition, which is basically circulating through the stratosphere after an eruption and then falling out over Greenland. And we can now directly see how a lot of these eruptions are much bigger than we've experienced in the past 200 years, say. They often occurred in clusters with much greater frequency. Let's go back to the Nilometer now and take the dates of 60 eruptions that have had some minimum estimated impact on the Northern Hemisphere climate, and average together all of the reported flood heights for these 60 eruption years, as well as those before eruptions and years immediately after. So that's what's shown in the graph at the top here. It's basically, it may look more complicated than it is, but in essence, all it is an average of the reported summer flood height from the Nilometer in the year of the 60 largest eruptions, where the red arrow is, and then for reference, in each of the years beforehand, each of the 8 years beforehand, and in each of the 8 years following. Sensor. Yeah, it's carbon dioxide parts per billion. Oh wow. Good to know we want. Okay. So what should become quickly clear, hopefully, is that the flood is much reduced during eruption years. And whilst this is what we might already have expected from sort of climatology and theory, it's only thanks really to improved ice core data since 2015 that we've been able to show this response systematically now using a large number of eruptions. We can say in the modern period, you might have looked at Pinatubo or some of the big eruptions and say, okay, the Nile looks like it's being impacted.
There are some people complaining about the audio quality. Can you mute your microphone for a second? And we'll see if we can fix it.
Hello, how's that, guys? Echo. Yeah. Oh, yeah. I've muted your one. Zoom. That this one is also, but maybe it's not. Let's just see. Okay, great. Thanks, guys. Okay. Okay, so we have now a good firm idea, at least for the common era, of what we should expect the Nile to do during its summer flood after a big volcanic eruption. Unfortunately, we don't have Nilometer data from the Ptolemaic period. There's scattered measurements here and there. There once would have been many Nilometers with systematic records up and down the Nile, with records stretching for millennia, but unfortunately most of these are lost. But we do at least have the ice core data and our dates of volcanic eruptions that do stretch past the Ptolemaic period, and we can be fairly confident at least that this sort of response would have remained largely the same. So we can hopefully infer when we see a big volcanic eruption in the Ptolemaic era that there would have been similar impacts on the Nile. So now let's look at volcanism during the Ptolemaic period. This graph plots out the ice core based dates of volcanic eruptions between 305 on the left hand side of the panel and 30 BC on the right hand side, so the Ptolemaic era. And the size of each blue bar indicates the magnitude of climate forcing, as it's known, in watts per square meters. Basically, this is how much solar radiation has been reduced reaching the Earth's surface because of the presence of these volcanic aerosols in the atmosphere. So more higher blue bar, more reduction in solar radiation because of the sulfate from these eruptions. Now, it's clear from this that the Ptolemaic period saw numerous explosive eruptions that are climatically significant, or at least potentially so, 24 in total, certainly more than we've had to deal with during the 20th and 21st centuries. So we don't know how we would fare under this level of climatic shock or this level of externally imposed climatic variability. At least 4 of these surpassed the size of the Pinatubo eruption in 1991, which we saw earlier. And the period actually effectively closes with the 3rd largest eruption of the past 2,500 years in 43 BC. That's it there, where I've actually flip off the height of the bar, probably goes up to height, if I was to show it fully. So an eruption of that scale is just really something beyond what we've experienced, or has been experienced by any contemporary society. Now, we can also take the dates of our prospective revolts that we've discussed earlier and simply just visually line them up alongside the volcanic event dates. Now, doing so, I think, at least to my mind, reveals quite a suggestive, when I say suggestive, that's important, correspondence. And it's also important to note that not all of them occur near in time to an eruption, and you wouldn't expect them to. These sort of revolts are going to be the product of complex social, political, and economic circumstances, even when there's an eruption potentially involved. And so we're not saying otherwise here. We're not using this information to replace established understandings, there's more to come and augment them or try and complete the picture by introducing some role for the environment here. Especially when the sources from the period itself actually call into question the role or highlight the question or highlight the role of Nile variability. Now, so not all of them correspond closely, but it looks like most of them do. And they're corresponding with these volcanic eruption dates, and what we now know are pretty credibly also the dates of probable severe Nile failure, when there wasn't enough summer flood water to grow sufficient grain. Now we can similarly plot out the dates of the 9 Syrian wars. These ongoing episodic wars between the Seleucids and the Ptolemies. And again, you see some suggestive close timings. And this is particularly the case with the apparent cessation dates of these conflicts. And again, to my mind, this does imply some role for Nile failure. Perhaps again, as with the earlier example of the end of the Third Syrian War in 241, a part of which is Ptolemy III's abandonment of his successful campaigning, the cessation of hostilities might have been repeatedly necessitated by revolt and or harvest failure at home, which coincided with eruptions. Now we can of course look much more closely at the timing of revolts relative to volcanic eruptions and also assess the statistical significance of any correspondence. Or put differently, how likely any correspondence we see is to have arisen purely by chance, since that's always a possibility still. So in 2017, I sort of co-led this study with Joe Manning in Yale, which tried to do just that. And here we see the same type of graph as we saw before for the Nilometer, where we are now showing the frequency, the average frequency of revolt dates relative to eruption dates again. It just looks cosmetically different. So in essence, the black line shows the average number of revolts in each of the 8 years coming up to our eruptions, just showing the years beforehand for reference. You could show 10 years, you could show 100 years if you wanted. The average number of revolts during eruption years and the average in each of the 8 years following, again, to perhaps see if there's any sort of prolonged or lagged or persistent response. And I think it becomes clear that revolts tended to occur more often during and shortly following, usually within 2 years, our eruption dates. And these are all totally independent dates. The revolts are dated completely independently of the ice cores. They may both have their uncertainties in them. They're pretty minor, I would say, at this point. But those uncertainties are independent of each other. So this is either coincidence happening purely by chance, or it's because there is some underlying causal connection between these two phenomena, ultimately, this outcome. This complex social phenomenon in terms of internal revolt against kings, stretching back to this geophysical event in terms of the volcanic eruptions. Yes, we have to recognize again that it's possible that these revolts could have coincided with eruptions just by chance. So to test how likely this is to have happened, we basically shuffle our revolt dates randomly. This is part of the statistical significance testing. You shuffle our revolt dates randomly many times over and over, and then you count on each shuffle the number of coincidences between eruption and revolt dates. And this gives us a sense for how many correspondences tend to occur just by chance when the computer is basically shuffling things randomly and counting correspondences. And then you compare that sort of randomly generated distribution to the number of revolts that you've actually seen occurring in the historical period. And what we do when we see that is that such a high level of coincidence, as we're actually seeing when we're looking at the actual historical dates, occurred on less than 5, sometimes on far less than 5% of the occasions when the computer is shuffling it randomly. So that's how you sort of test how likely the sort of correspondence is to have occurred randomly. Now that's just a guide. It could still be a chance correspondence. but at least we can inform ourselves with a figure about how likely that is to have been. And we also have some idea, hopefully, of the mechanisms that why it would make sense that a causal link like this might exist. Now, if we do the same for the cessation dates of the Syrian wars relative to our volcanic dates, we can show, even in the absence of written sources explaining why, or telling us anything really informative about why an eruption or why a war ended on a particular date, you can see that this is not an isolated occurrence, that there's an increased frequency of wars terminating during or shortly following these eruptions. So this again makes some sense if the Ptolemies had to rapidly abandon costly campaigns to manage or prevent crises at home, also spending money on importing grain, as we saw in the Canopus decree, rather than pursuing costly warfare. And at the same time, it also suggests just why the Ptolemies were, I think, trying to secure those external territories that were capable of rain-fed agriculture, independently of whatever the Nile was doing, so that grain was available for import, perhaps particularly during years when the Nile had failed, so to speak. Okay, well, so that was the Ptolemaic side. What can we say of the Seleucid side, the Ptolemies' great rival? Well, unfortunately, we're not as much right now. Maybe that's a relief. Maybe not, but our work is much more preliminary here, and the Seleucid kingdom is not as well documented as Egypt. But we do have good documentation from Mesopotamia, which was an important part of the Seleucid kingdom economically and symbolically as well, not least because of the presence of the Tigris and Euphrates rivers and Babylon itself, which was a great symbol. They're all pictured here, as well as a sort of reconstruction by Robert Adams of the extensive irrigation networks that were built between the two rivers, something that the Seleucid kings also expanded on. Now, perhaps of most immediate interest are sources known as the astronomical diaries, and they're preserved in cuneiform script on baked clay tablets, the same type of tablets that preserve so much of Near Eastern history. Now, pictured here is the diary for 273 BC, which incidentally mentions the role of Babylon here in providing resources for the Seleucids during the First Syrian War, and possibly relatedly the incidence of famine and disease in and around Babylon at this time, which you can see sort of excerpted on the slide there in quotation. Now, many dozens of diaries like this containing huge volume of weather observations that were made systematically on a daily basis between the 5th and the 1st centuries BC by professional astronomers based in Babylon actually survived thanks to the medium. And even if you were to burn down an archive, in fact, this only tends to preserve these tablets by baking them hard. So when you're an enemy coming along, you're burning down buildings. This is actually active in many cases to preserve these sources for once. Now, these texts have been carefully compiled and translated by scholars, and we've made particular use here of the impressive compilations and translations by Sachs and Hungers. So we don't need to learn the Akkadian, thankfully. Not that that's not a worthwhile thing to do. Now it's reasonable to believe also that major eruptions would certainly have had some impact on Babylonia as well, in part because of the close match between ice core eruption dates and the somewhat cryptic reports in the diaries. Most of the reports of weather are very straightforward. It was cloudy, it rained, it was cold, there was dust, and so on. The wind was coming from a certain direction. Like, they are amazing sources, but they also have these more cryptic observations, perhaps involving things that the diarists themselves weren't familiar with, or were not fully certain of the cause of. And one in particular, a report that keeps popping up, is that the disk of the sun looked like that of the moon. Now, observations of unusual dimming or discoloration of the sun are actually quite common following big eruptions, like the milky white sun that you can actually see here in Leiden after that 2010 eruption of that unpronounceable Icelandic volcano that shut down all the airports for a few months in Iceland. And now this is generally caused again by sunlight being blocked or refracted by the fine particles of sulfate, and also perhaps ash that have been injected into the high atmosphere by an eruption and producing sometimes spectacular visual effects. You might have heard of volcanic sunlets or volcanic twilights as well, unusually red twilight skies. That's again caused by the sunlight coming and making its way through sulfate. And that sort of visual spectacle has ensured that historical observers, like the authors of the diaries, and perhaps particularly like those who are professional astronomers, would take notice and record these sort of events. And these are usually sort of more colloquially called dust veils, although often it's sulfate and not particularly dust or ash that's causing these effects. But here's a graph that shows the volcanic sulfate signals in the Greenland ice. These are the black spikes from 270 BC onward. And the red and the blue X's are possible dust veil observations, including many from the diaries. And those which were colored red, which are in the majority, are and too many to have happened randomly, date very close in time to the volcanic signals in the ice. And in fact, this match was so good that we were able to use these historical observations to show in 2015 that revisions to the prevailing ice core chronologies and dating schema that prevailed for several decades beforehand were correct. And one of the things that came with that exercise was the realization, and we had Mike Bailey, who contributed pretty much as one of the first observers of this dating offset, where that in the first millennia AD, the established ice core chronologies were wrong by about 7 years, although they were thought to be accurate. And by the time of our period, they're wrong by about 9 years. So when the new ice core dating was being developed by Michael Siegel, we kept these dates as a sort of independent control. When you look at the sulfate spikes on the older chronology, you don't get any of these matches. When independently he redated the ice cores by various means, all of a sudden this match appears. So we were able, it's a nice example in passing of the use of independent historically dated evidence to help out the natural scientists with what they're doing, basically. So this is at least showing that the dust veils are visible from a lot of these eruptions over Babylon, so we can expect at least some sort of climate impact. Now, one of the more remarkable things that are noted in the diaries by the court astronomers is the height of the river Euphrates at Babylon. They would actually go on a monthly basis to a certain bridge in the city and drop a rope down to measure how far the water level was down in any given month. And they did that systematically for centuries. It's really an incredible feat. Now, this graph is the same type of analysis you've seen already for Egypt and the Nile, but it's just cosmetically different again. It covers the period 383 to 75 BC, when we have most of these diaries surviving in greatest density. And it shows in the blue line the spring-summer flood height of the Euphrates at Babylon, again in the 10 years before, in this case 11 major tropical eruptions in this period. For reference, the year of these eruptions at 0.0 on the horizontal axis, or where I put that arrow, and for reference, and see if there's any persistent effect from these eruptions for the 50 years following. And we show 50 years here after eruption dates, not because we expect that the eruptions would meaningfully be able to influence the river even 50 years afterwards, but just to help show how anomalously high the flood is in these eruption years. So this is obviously the complete reverse of what happens to the Nile, and was initially quite unexpected, at least to me. But we can draw on some climate modelling to help corroborate this result and explain what might be going on. The Nile is doing something completely different to the Euphrates. This image shows simulated annual mean precipitation anomalies after the famous 540 AD tropical eruption, which so many people have studied, including one of the first people, Mike Bailey, as well in Belfast here, relative to a 1,000-year non-volcanic control one, basically looking at what the model does when you simulate a volcanic eruption and comparing it to what it's doing when there's not a volcanic eruption being simulated, using the fancy Max Planck Earth System model. Now, basically, without getting into too many details, it shows anomalously wet weather in the ancient Near East and Babylonia, and importantly in the Armenian highlands, in which the Euphrates actually rises following this tropical eruption that's been modeled. So that matches well actually with what we see in the diaries, with an increased Euphrates spring-summer flood heights following our ice core based dates of tropical eruptions. So while the Nile might be dependent on the African monsoon, the Euphrates is actually much more impacted by what's going on in regions such as the North Atlantic, in particular how much moisture is being swept westward or eastward from the west over the Armenian highlands each winter by the sort of westerly airflow, the same that delivers us most of our rain here from big depressions and storms, and depositing over those highlands snowfall effectively that drives the spring summer flood of the Euphrates when it starts to melt. So there's a lot of linkages you have to start putting together here between your historical evidence and the climatology that you know about in the modern period and what you can infer to have happened in the ancient period and so on. So it looks like volcanic eruptions, in any case, tropical eruptions, can increase this snowfall, leading to greater flooding and potentially actually benefiting Babylonian agriculture. Look, there's a huge amount of work still to be done to understand really how this might now have impacted the history of Babylon, to start integrating that sort of knowledge into the history of the region and the period. But at least with this mix of evidence, we now have some new questions we can ask. For example, whether this fed into the conflicts between the Ptolemies and the Seleucids, with the eruptions not just only disadvantaging Egypt, but perhaps also simultaneously actively advantaging the Seleucids. So we can actually see if the sources, the written sources, the archaeological evidence starts to bear this sort of asymmetric dynamic impact from the environment out in terms of what happened in these conflicts and when they happened and so on. Okay, we can certainly, as first steps, how much time do I have? Almost up. Okay, we can continue to look at the economic effects of the same eruptions, at least in Babylon. And we can do so again because the same astronomical diaries also furnish a tremendous volume of economic data as well as recording weather and astronomical events and what the river was doing. They also were recording the diaries monthly and even daily market prices for commodities like barley and wool in Babylon. So it's an amazing and immense record. That's definitely not as widely known about as it should be. Now, the price data itself has been of great interest to economic historians to date, even though the weather data has been more marginalized or ignored. But the price data, at least, has been described as the most detailed data set of the ancient world, which can compete with data sets from modern history. And on the graph here, we can see periods of relative price stability and then periods of relative volatility that are still of uncertain origin, although people like Robertus van der Spek have done a lot of work on trying to decode this variability. And now we're trying to add in more of an environmental context to see what that can contribute to. So we obviously, again, want to examine here what role there might be for climate, among all the other possible factors like warfare, population change, technological change, and so on, that has already been studied. And there are, again, many analyses that you could use to do this, but for the sake of continuity, because I love this type of plot, we look again at the average prices before, during, and after our volcanic eruption dates. And that's what this graph shows, taking the case of barley prices. Now, given that historical volcanic eruptions are generally thought to have negative social societal impacts, that's generally what you get from the literature when you look at the impacts of volcanic eruptions on medieval societies and so on, due to the extreme weather that they're associated with. It's again a bit surprising here to see them associated with actually unusually low prices. Generally, it's historically high prices that are stressful, and that's what the economic historians would often focus on, leading to food riots and so on. But here, in the volcanic eruption dates, you have unusually low prices. So that again was unexpected, but again, perhaps it shouldn't have been, because we know that Babylon irrigated heavily. That's how it drove its agriculture from the Euphrates. So if there was actually more water being available than the Euphrates because of the eruptions again in a given year, this might actually have been beneficial to the society overall, and they had increased grain production. So we can actually start to put some fill in the blanks about how one society may be advantaged and another society, interestingly, both often at war with each other, were asymmetrically impacted. Case. But that's just one strand of evidence. There's a lot more to look at. Now, to come to a close, if we return to Ptolemaic Egypt, one aspect of the story is the eventual collapse of the state in 30 BC, with the nominal cause being Cleopatra's defeat to Rome at the Battle of Actium in 31 BC. Now, when we published some of this work in 27, the media effectively themselves made the connection between volcanism and the collapse of the state, even though the paper wasn't really about the collapse of the state. It was about what happened through the 304 other years. But you can find headlines like "Volcanic Kiss of Death," pictured here. And so, yeah, there might have been a role for volcanic impacts on the flooding of the Nile in the fall of the Ptolemaic kingdom. Certainly in the decade before, as I showed, you did have, on a previous graph, the third largest eruption of the past 2,500 years in 43 BC, and there were terrible impacts that you can see associated with that in the historical documents in terms of harvest failure, mass migration, disease, and so on. But its role is still going to have been certainly complex on something like the fall of the kingdom. For example, despite the impacts of that eruption that you can see in the documentation, there is actually no case of organized revolt following this biggest volcanic eruption of the period. And Cleopatra is known to have taken measures like banning export of grain at the time, releasing stored reserves and so on. So mitigation measures, for example. But it seems, at least to the media in any case, that collapse is a more glamorous topic than resilience or adaptation in any case. Now, to continue the theme of resilience and adaptation, I have in the time available really sort of skipped over a lot of interesting developments in the period and the broader region of Egypt and the Near East. Certainly, the story that we want to take away is not that this is a case of hapless human societies at the mercy of the climate or the environment. The Canopus decree itself of 238 BC already suggests how effectively the state might respond to environmental stress through grain imports, taxation, tax reductions, and so on. And the period is also known as one of remarkable technological advance, not least with the Sakia, which is a mechanized water lifting machine thought to have been invented in the 3rd century BC in either Egypt or the Near East. So at this time, in any case, and still in use in some areas into the 20th century. Overall, this is really just a brief sample, actually, of some of the work that is ongoing on volcanic impacts on societies historically, taking advantage of the fact that for the first time we got very precise dates of climate shocks to the system from the ice cores from these eruptions. There are many other types of climate change that you could examine, but few of them are dated so precisely so far back in time. So we're basically just using what's available to us. And also, at least when you see these volcanic eruption dates in the ice, you can at least assume, but you need to test your assumptions, of course, that this could be a potential climatic influence, so almost global climatic influence. So almost any period or society you're looking at, these data could be relevant to. So that's sort of nice. And in the case of Egypt and the Nile specifically, there's also probably an important contemporary relevance right now. So we have the ongoing construction of the Grand Ethiopian Renaissance Dam on the Blue Nile, which will be able to store a considerable amount of the summer rainfall in Ethiopia that would usually be drained by the Blue Nile and then supply this summer flood. Now, given that Egypt remains massively dependent on the Nile, even with its own dams, this construction has clearly worried them. And President Al-Sisi has basically suggested he'll bomb the dam if there is not a satisfactory water sharing agreement reached. Now, they're currently inching towards an agreement, but it's sort of worrying from my perspective that there's no real discussion for how the agreement is meant to operate if and when the next big eruption causes a real shortfall in precipitation. Will the agreement be able to withstand that sort of stress or that test? Or if indeed when there may be deliberate mimicking of volcanic eruptions through geoengineering, which is where you put large volumes of sulfate artificially into the stratosphere as a way to combat global warming, which there are scores of research papers on each month. So it's something seriously being researched and considered. Now, I think this is a case, at least, where the work of historians and archaeologists and natural scientists is clearly pointing in the same direction on an issue that will impact potentially millions of people in Ethiopia, Sudan, and Egypt, through which the Nile flows. And perhaps if we join forces, we might be heard a little bit better in this respect. And so I think it's also an example of why the existence of the Crossing Frontiers network here and events like this lecture series have a real importance. Thank you.
Thank you very much. Can you?
Of course, yeah.
Just keep in mind. So thank you very much for a fascinating talk, and I'm sure there'll be lots of questions from both mine and so maybe I can just kick off with one question. So what people start thinking. Very cleverly point. And this is something that we have noticed for tens of period during the Tang Dynasty, and other periods in which, in a particular historical period full of political turmoil, it looks like natural phenomena, environmental phenomena like earthquakes were recorded more often.
Oh yeah, okay.
So it seems like in a way that created a correlation between what was happening. They were politicized in that sense, what was happening in the States and what was coming from, from heaven in that sense. So, and this Risa Raffals refers to this as mantic narrative, examples of mantic narrative. So what I guess I want to ask you is, because you pointed out also the political period, historical period, do you think there may have been other records that didn't filter, but because happened in other historical periods which weren't as complicated, politically complicated and controversial in that sense? I guess I'm just asking you what the correlation do you think might be and how this phenomenon could be politicized?
Yeah.
Criticize.
Oh yeah.
The monarch or the emperor.
Yeah, no, there's no doubt that these events are politicized in China, certainly. You have the Astronomical Bureau there established, and I think there's even some censorship of certain types of extreme events that won't reflect necessarily favorably on the emperor, for example. And in the Ptolemaic period, one of the things that the Ptolemies did was pretty quickly adopt the mantle of the pharaoh. So they took on that title and all of the things that came with it, including responsibility, nominal responsibility for how the Nile was flooding each year. So they take on a personal responsibility for Nile failure. So there are obviously advantages taking on the mantle of the pharaoh, but it comes with this politicization, and that was definitely ongoing. And there is some evidence statistically that during some of the less favored reigns, that there is more recording of bad Nile years. It's not necessarily that these are fabricated, although sometimes they might be, but just more there's a bias to reporting bad events when a particular pharaoh or particular Ptolemy who is not as beloved by the masses is reigning. And I suppose this is why we have the advantages of the ice core dates. They are totally independent of the dates we get from the historical sources. So each of them will have their own biases and uncertainties, but they're both independent, or they should be both independent. So when you still see them lining up on average, that should tell you something sort of powerful.
Yeah, I guess, no, that's great. And I guess the point is also what I was thinking, like, of course, this phenomena happened. And as you said, we know that, but whether they kind of incentivized the political revolt because of the significance that was attributed to them. Do you know if that's?
Yeah, so there's some documents I haven't, there are, what are they called, oracle texts from the period and they're originating with the priestly caste, and some of the priestly caste is obviously supporting the Ptolemies, and they've got material incentives to do that with tax reductions and so on. But there are also these oracle texts which are blaming the Ptolemies for Nile failure, for invasions that are happening of the land, and blaming them for basically everything. And they're explicitly drawing upon that association that would be well known by the Egyptian populace between the pharaoh and the sort of what the environment is doing, basically. So they're really capitalizing upon it yet too. In some cases, there's the Oracle of the Potter is the most famous one. It's basically trying to motivate and foment revolt effectively by calling attention to what was obviously Nile failure. It even mentions darkening of the sun, and all of this was thought to have been allegorical, but we now know probably the sun was darkened pretty much repeatedly during this period. So they may have been capitalizing on actual events too, and these sort of mental links, psychological links.
Thank you, Francis. Any questions from people both in the room and online?
Questions from
online
just to start. So, firstly and by the way, because there's only one mic, can you repeat the question?
Oh yeah, sure.
So, I think you mentioned as statements that some looks like this quite common. How often does this, and does it or does it not?
Yeah, so this question is about the remarks in the astronomical diaries of the disk of the sun appearing like that of the moon. It's common. I think it occurs about 12 times. So it's still in the minority for more run-of-the-mill type of weather events, like it was windy this year, it was cold, but enough to do some statistics with for sure. And I think the vast majority of them correspond with the independent dates of the ice cores for big sulfate spikes. So they're basically reports, in my view, of volcanic dust fails that just have gone unremarked upon. So yeah, no, and sometimes there is independent observations at the same time from China, you know, of the sun, it looks discolored and so on. So all the story sort of adds up to these are dust fail observations, yeah.
Second question. Did the Zubo event lead to a weaker now years after 19?
Yeah, it wasn't massively weakened, but the impact of it at that stage would have been compensated for by the construction of the Aswan dams, the upper and lower Aswan dams. So there was enough storage capability in these dams in Egypt to sort of compensate for that event. What it seems to be is that a tropical eruption won't have as much an effect as on the Nile, at least, as higher latitude Icelandic or Alaskan eruption, just because of how the monsoon airflow reacts to where the aerosols are coming from. That's quite complicated. But so the 43 BC eruption, it looks to have been an Alaskan eruption, as we can tell now in recent work, and it would have had an outsized impact on the Nile, even if it was smaller than Pinatubo, just because of where it was. So the eruption location, to cut a long story short, is very important too.
Third question. Is there any similar evidence?
Yeah, no, absolutely. There aren't as many dust fails reported or that you can identify clearly as dust fails in the Irish annals, but there are occasional reports in 627 of a dark year, and that's corroborated by some reports of the sun being dimmed from Near Eastern sources, and that also corresponds to a massive volcanic signal in the ice. Again, only under the revised or improved ice core records. Again, there's a report of the sun being discolored for a period that's too long to be just a normal solar eclipse in 939, and that also corresponds to a big volcanic eruption, even historically known, even if the date historically is a bit wobbly, of the Elja fissure volcano in Iceland. So yeah, there is not so many as when you look at the astronomical diaries, but then the Irish annals weren't designed to be systematic weather or environmental phenomena observations.
Maybe we can see if there is any. Is there any question?
Francis, I've got two questions to go through, as always. First is about areas that I appreciate actually not very personally that massively interesting period. It just gives you a set of sources on is your best as an ecological model.
Yeah.
Babylonia, 19. Where would you expect the next step?
Yeah, we looked at.
To repeat the question.
Oh yeah, so Emma has asked basically if there are other periods and regions where you can conduct a similar sort of analysis, where you have the same sort of mix of sufficient documentation to look at human responses, and well, anywhere in the modern period, obviously, really, but in the pre-modern periods, yes, places like China, and also which we've looked at, and yeah, we were looking at the transition dates between dynasties. In the Common Era, there's about 68 dates. This includes some minor satellite kingdoms, but they had dynasties or styled themselves as having dynasties after the sort of more Han Chinese Empire, and those dates are pretty reliably known, and they're associated with volcanism as well. Not all of them by any chance, but more of them than you would expect randomly, a lot more than you would expect randomly. So these transition dates between one dynasty and the other, sometimes very violent, sometimes as with the Mongol invasion and the establishment of the Yuan dynasty, that was very, very destructive. Other times you only kill the royal family basically, and then you so but all of these transitions are statistically associated on average. And what we saw there is it's really the historical context is paramount here. So when we were doing this analysis, and that's published last year, probably Google that, we were seeing that there's volcanic eruptions as dated by the ice cores were associated with these transitions, but there seemed to be no apparent relationship between the size of the eruption and the likelihood of a transition. There were often transitions following from one dynasty to another following very small eruptions that would have had maybe a more minor climatic impact, just as often as there was with big eruptions. And there were many big eruptions that had nothing, which what you would expect because the society is fairly robust anyway. And what we saw is we needed to add in extra variable. We added in levels of pre-existing societal stress in forms of how much war was going on in the society through time. And so what you seem to have happened in China was if there was high levels of pre-existing warfare and a volcanic eruption came along, then you had a higher chance of a transition or a collapse of the dynasty, you could say. But if the warfare was small or there was none, you tended to have a much more massive eruption to get that chance of a transition to increase. So it's all about how stressed the society already was at the time of an eruption randomly coming along and messing with the climate. So you really need that extra ingredient. What the society? It's not deterministic model. You have to understand how vulnerable the society is at a given time.
This leads me to the same question. This is about what I find really striking is you have volcanic eruption impact, opposite impact depending on the geographic space.
Yeah.
You also have spaces where you have.
That's right.
The question is, would you have certain entities, say, where you can cross their range and not they in the Africa area. That's an eruption has either additional.
Yeah.
You have the stable area that eventually stable was not.
I think this remains to be seen, but it's a great question, and that's so. Oh yeah, sorry. So are there areas where not only you might have a society that is advantaged or disadvantaged, particularly by a volcanic eruption, given what it does to the climate, but areas that also don't have much effect at all? And can you see that sort of play out in the history of these societies? The example is the Roman Empire, and I think yes, but that work needs to be done convincingly yet. And we need to still keep up with our climate modeling to try and fill in. These proxies that we use are very regionally specific, like tree rings and so on. So there are a lot of places, especially in Egypt, for example, where you don't have good tree rings and you're very constrained in your natural archives and sometimes your written archives about what the climate was doing. And you can use the climate modeling to sort of fill in the gaps spatially between those areas. So yeah, it's a great question. Lots of work to be done pursuing exactly that line of investigation.
Yeah, if you've got any questions. Amazing stuff. I guess you could, because Nazim was saying, like to other different civilizations and actually see if there is any path.
Yeah.
In that would definitely strengthen your.
Yeah, I go anywhere that there's a good density of written sources, and that I can get collaborators that are willing to, they're expert in the region and the period and the languages and
lack of, as Nazim points out, lack of volcanic eruptions. Does it mean like more stable?
Yeah, well,
kind of society, less political revolts. Do you know that? Yeah,
there's the Roman optimum period, I think, which is now sort of the first 2 centuries AD. When you've got a very expansionist Rome, that has been remarked upon already as being very quiescent in terms of volcanism. that has been noted several times. In terms of being more sophisticated and it's very hard to say that the absence of something. It's easier to say here's the presence of something and the presence of something else. But it's still a legitimate question. It's just harder to pursue if the absence of something leads to the presence of maybe an expansionist or a golden age or something in a particular society.
Kieran, are there no questions? No?
No question.
No questions from the room. So can we just thank Francis again for a fantastic paper? So thank you, everyone, both people in person and online. So I hope you all have a nice evening. Bye.
Thank you.
That's great. And
Sorry for all the coughing, but
no, that's okay.